Hello everyone. Thank you for joining our session. Today, we'd like to talk about VirtIO update on VirtIO CTS and integration of VirtIO CTS, RTC and Virtio-media into AGL. I'm Kazuki, and I start with the background and VirtIO CTS part. And later this session, my colleague Yuki Teramura will take over the session and introduce VirtIO RTC and media integration. So before getting started, let me briefly introduce myself. I'm Kazuki Kuzu from Panasonic Automotive Systems and a member of AGL UCB expert group. And I have been working on embedded system and hypervisor-related topics for 6 years. And outside of my work, I enjoy PC games, skiing, and I like meat, whiskey, and green tea. And here is the agenda. So first, I will start with the introduction of background. And second, VirtIO CTS. I will explain the VirtIO CTS concept and roadmap. And finally, this session will move on to the integration of VirtIO devices. And this part will be covered by next speaker. And let me start with the introduction. So in software-defined vehicle, virtualization and VirtIO plays an important role by consolidating multiple systems on high-performance computers. Virtualization simplifies the software update management. And this is valuable in especially automotive systems where updating software management, managing software update across multiple ECUs has become increasingly complex. In addition to that, hardware abstraction provided by virtualization allows software to be developed and validated in environment different from the actual vehicle hardware, such as cloud, and this achieves cloud-native development. And this also makes it easy to port software to the next generation hardware. And VirtIO further enhances the benefit of virtualization. The VirtIO provides a standardized paravirtualization mechanism, and by decoupling software from hardware, it improves the portability across different hardware platforms. So far, I've talked about why virtualization and VirtIO are important in SDV. In this slide, I'd like to shift the focus to our effort to enhance VirtIO in this context. First, in automotive systems, long product life cycle and strict requirements often lead to proprietary or customized VirtIO implementation, and this can cause fragmentation or reduce the portability over time. And VirtIO conformance test or VirtIO CTS address these challenges by verifying the compatibility of the VirtIO device implementation. And second, as VirtIO evolves, several new device types are standardized in OASIS VirtIO version 1.4, including CAN, SPI, media, and RTC. And among these, we integrated VirtIO RTC and media into AGL to support automotive use case. And next, I will briefly explain what VirtIO CTS is. The VirtIO CTS provides a unified cross-hypervisor validation approach to ensure conformance with OASIS VirtIO specification. All tests run from the guest OS perspective to verify that VirtIO device behaves as expected by a generic guest operating system. The architecture is platform independent and avoid hypervisor-specific dependency, allowing consistent execution across multiple virtualization platforms. VirtIO CTS also provides two test approaches: a unikernel-based test for fast basic compliance check, and Linux-based test for more complex device validation. Regarding our future plan, we are targeting an initial open source release of VirtIO CTS in November 2026, and also planning to demonstrate VirtIO CTS with SODEP at the coming AMM. So that concludes the VirtIO CTS part of this session. So next, my colleague will take over.
Next, I will introduce the new VirtIO devices we plan to contribute, along with a demonstration how they work. Before presentation, I'll introduce myself. I'm Yuki Teramura. I've been working on embedded system and hypervisor-related tasks for about 3 years with Kuzu-san. Outside of my work, I like cooking, especially making lunch boxes, and this hotel's lunch give me a big inspire. Okay. We will integrate the newly defined Virtio-rtc and Virtio-media from the OASIS VirtIO 1.4 into Yocto and contribute them to AGL. Virtio-rtc provides time synchronization between the host VM and guest VM, as well as alarm configuration capabilities. This is important because existing solutions are often proprietary and don't provide sufficient accuracy or functionality for real-time automotive use cases. With Virtio-rtc, we can properly handle time during guest VM, suspend and resume, and improve cross-VM debugging using consistent timestamps. Virtio-media, on the other hand, focuses on media and camera virtualization. It virtualizes the V4L2 user space API for camera and codec devices and exposes them to guest VMs in a standardized way. The motivation here is the demand for full V4L2 virtualization in automotive systems, especially for camera, ISP, and camera capture, encode, and decode pipelines. While VirtIO video mainly target codecs, Virtio-media enable direct usage of camera hardware from guest VMs, which is essential for many automotive use cases. This is an overview diagram of the Virtio-rtc. The VirtIO backend is provided as a vhost user and retrieve time information from PDP or clock source located in the host VM's kernel layer. And this is Virtio-media. The backend is provided as a vhost user, just like Virtio-rtc. Virtio-media uses V4L2 as its protocol and virtualized only the V4L2 video device API. Next, I will show you a demo video of each driver in running on AGL. The execution environment is shown here. AGL is used as a guest VM. Okay, the bottom of the part of the screen it runs each backend socket on the host VM. This is RTC. And next is Virtio-media. For Virtio-media, the backend socket is configured using the media device physically connected to the host system. And next, we boot the guest AGL using QEMU. The detailed source code is included in the appendix, but since it consists some parts that have not yet been merged into the upstream repositories, the full functionality will be available after the contribution is completed. The manifest version we are using is Unagi 21.0.0. To demonstrate Virtio-media, we run the camera application service using IVI demo. You can see the feed from the web camera connected to the host PC on the guest VM. In this demonstration, the feed is shown via TZC, causing slight lag due to the guest VM emulation, but this is improved when using KVM. Next, RTC. Two types of devices appear in RTC class, and you can confirm that Virtio-rtc retrieve in present. In addition, by checking the dmessage log, you can confirm that Virtio-rtc is used as the system clock source during boot. Furthermore, three PTP devices are visible under the PTP class, and their clocks name indicate that they originate from Virtio. Next, using phcctl command, we can retrieve the time from each PTP device. You can verify that each one has a different clock types. Okay, next, we demonstrate alarm functionality. We set the wake up alarm on the Virtio-rtc to trigger after 5 seconds. Then suspend the guest VM. When the alarm expired, the VM resumes automatically. You can also confirm that the GUI in the background was suspended during this period. As you saw in this demo video area, we identify an issue in Virtio GPU during the integration of Virtio-rtc. The reason that the UI continued to run during suspension and the black screen appeared after resuming is that the suspend and resume functionality for Virtio GPU has only recently been defined in OSIS Virtio 1.4 and has not yet been implemented. As a result, rendering does not stop and the GPU is not reinitialized. Although outside this scope, it highlights a key gap. Automotive systems require proper suspend and resume, so Virtio GPU backend must keep up with OSIS updates. We plan to contribute Bimba. Please stay tuned for the upstream release and when it becomes available. That concludes our presentation. Thank you.
great work. I would like to ask specifically about your time synchronization part, because I found it pretty useful in our data loop case. So there is a situation that when you're using ADAS or any video cameras for the self-driving, when a car crashes, it's pretty hard to synchronize the time frame between the across different domains. So this is also a particular issue for the data loop, closed loop of ADAS system. So is it possible to use your VirtIO to synchronize the video frame, video streaming data with other domains like powertrain, like BCM, like cockpit? So we have need to the precise time alignment between the different data stream to understand what's going on in the very moment when car crashes. Yeah. Otherwise, if the time is misaligned, the issue is gonna be totally different. Yeah.
It's a bit hard for real-time domains because usually stopping the video stream from the camera cause some fault detection mechanisms happening, and it gets into the fault recovery mode automatically, so that missing some packet of the streaming packet type of things is really difficult for simulating in this kind of environment, I think. So it's either domain it will be okay, I guess.
Okay, thank you for yes. So this VirtIO-rtc is basically provides the PTP for the kernel, and the application usually use the PTP timer or arc timer to get some time. And so in ADAS domain, so that is critical to get the how to say the correct time is very important. But so currently we don't have a correct answer to use the VirtIO-rtc into the ADAS and IVA domain. So but it is a very interesting point.
Yeah, it's a tough question, I know. Yeah, as Murata-san said.
Thank you.
But I believe it is a promising direction. Yeah.
Okay. Thank you.
Thank you for very great work. So I have one question. So do you have any plan to CTS performance test? Because Murata-san said some hypervisor happen to performance issues. So I'm fully agree this comment. And 3 months ago, I'm one debugging commercial license hypervisor, and this software, for example, VirtIO block is a very easy interface. However, performance is very depend on host OS and guest VM VirtIO block software programs. So, for example, this issues host OS EMC access is so-so, and guest VM is very bad. But CTS, for example, in Android case, have some test case include a performance test. Yeah, because the performance test is very important in their product. So do you have any plan to support a performance test about CTS?
Okay, thank you. So that is very important point. And currently, the VirtIO CTS is targeting to check the compliance with the OASIS. But as you know, the performance issue is very important for automotive use case. And so, but additionally, you said the performance is very depend on the platform and hypervisor and the entire system configuration. So it is a little bit difficult to check the conformance for the performance. So, and Android CTS has also the performance check, but the Android has a CDD to, how to say, so promise the exact behavior. So if we want to check the virtualization platform is conformance to some case, we have to define the like CDD or anything for the virtual hardware. But so in automotive system, the hardware and system is varied for in the automotive system. So currently, it is very important, but we don't have the concrete idea to check the compliance for performance.
This is my idea. So AGL have a reference board, for example, Renesas V4H Sparrowhawk, and another is a Raspberry Pi, and very easy to compare them to spec to in real product. So in this means if AGL provides a reference board and performance test result shared to everyone, and we very easy to compare them in real product. Because the hardware spec and software spec is very similar to configuration and software diagram. So this is my idea. So please work together to these topics.
Yes, thank you. So that is very good idea. So the overhead can be evaluated with a specific guest operating system. So if the AGL or MC can be that stuff, then we can compare the overhead or some performance in the various real product hardware. Thank you.
Yeah, thank you.
All right, thank you very much. That was Teramura-san's first presentation in English, right?
Yes.
Very good.